Welcome to the Mr. McMurdo Math Maniacs Math Network. Today, we're going to go over some stuff to try and help you out because you want some good grades before Santa comes. It's hard to get presents before Santa if you don't have good grades. So in the first class on the what has a bottom at the top, and the second class what has a bottom at the top, already recorded and posted today, 1, 2, 3, 4, 5. You can find 6 of the answers to what has a bottom at the top already posted on the Tube of You, posted today, December 6, 2017. So if you needed the answers, if you needed help, you could find some there. So I'm going to go over some of those. Also, I'm going to go over some of the orange cards. Now, if you think about it here, I've done 2 problems of the orange cards in my first class and posted it. I did 2 problems of the orange cards in my second class and posted it. In this class, I'm going to do 2 problems on the orange cards and post it. And then after school, I'll do 2 more of them and post it. So by the end of the day, by the time I leave work, let's see, that's 1, 2, 3, 4, 5, 6, 7, 8. I'll have done 8 of the 8 orange cards, shown the steps, shown the answers. So anybody who doesn't get 100 on the orange cards, then I just have to say, that's because you Lazy.
Lost? Lazy.
Don't be lazy. Don't be lazy, kids.
Oh. She asked if I said lost. Yeah. Lost has a Z in it and a Y. Let's tilt this up just a tad bit here. All right. So, as we get started, I'm just going to tell you right now, number 21 is 1/6. So if you want to write things down so that you have them, maybe on paper, Brooks, that might help you. I've also done problems 16, 17, 18, 13, and 9. So 16, 17, 18, 13, and 9 have been done and posted on the video. You have to show the work anyway, so you might as well write it on paper. JJ, you're not allowed to sit on that. I fear for your safety. Since you've proven 2 days in a row you're not safe to sit on that. All right, so I'm going to do, let's go with 15 is the first one we're going to do. Brooks, if you're not going to pay attention, then sayonara. Well, don't talk to him. So let's try 15. Which it looks like that problem is 8/15 multiplied by 9/4 multiplied by 11/12. Now, when we got to the time in your life when you had to multiply 3 fractions, which was probably this week, some of you freaked out and were like, I don't know how to do it. It's got 3 fractions. Well, if I told you to multiply 3 times 7 times 2, you would just multiply them. Doesn't matter what order. And it's just 3 numbers you're multiplying. It's still just 3 numbers you're multiplying. Because you multiply the numerator straight across and the denominator straight across. So for our new numerator, we have to multiply 8 times 9 times 11. Because I'm cool like this, I can do it any way I want. I can multiply in any order. So I'm going to start with 9 times 11, which gives me 99. Then I'm going to multiply that by 8. So if I have 99 times 8, 72. 72 plus 7 is 79. So my numerator here is 792. Fairly easy. Really, multiplying fractions is a whole lot easier than adding and subtracting fractions. I'm just saying. I'm just saying. Then I have 15 times 4 times 12 is going to give me my denominator. Let's say 15 times 4 is 60, so I need to do 12 times 60. Since my second factor has a 0 in the ones place, I can just leave that 0 straight down here. Boom. And then I'm just multiplying 12 times 6, which is 72. So this one would be 720. So now I have the fraction. You writing this down? Writing it down? Right. So now I have the fraction 792 over 720. JJ, what kind of fraction is that? Improper. Good. Don't touch that chair. Good. JJ knows if the numerator is greater than the denominator. That is an improper fraction. JJ, how do I fix an improper fraction? Good. This says the same thing as 792 divided by 720. That's what that problem says. 792 divided by 720. That's what a fraction is. This one says 9 divided by 4. 11 divided by 12. Fraction sign is a division sign. In this case, we're just going to leave them as fractions. But we're going to divide 792 divided by 720. JJ, does 720 go into 7? No. You're touching the chair again. Does 720 go into 79? No. Does 720 go into 792?
Yes.
Yes. I'm going to have a one-digit quotient. Just a one-digit quotient. Only one digit in my quotient. How many times do you think, JJ, 720 is going to go into 792? One time. And if I subtract there, I get 2, I get 7. So now I have one remainder 72, or 1 and 72 over 720. Now, JJ, I'm looking at my portion that says a leg, because that's what has a bottom at the top, because you see, this is my leg, goes up here, and that's my bottom, has a bottom at the top of my leg. I'm just really just saying. So, JJ, since that's not on my little puzzle, what do you think I need to do? Excellent. Yes. Okay, I could find the greatest common factor. Can you tell just by looking at it what the greatest common factor might be? If I divide these both by 72, pretty easy. JJ, what's 72 divided by 72? 1. And JJ, what's 720 divided by 72? Most awesome. So now I have the fraction 1 and 1/10. So whatever number this is, I don't recall. When you show your work, I should see this, because you have to turn in the work you showed. Otherwise, I take off points. And then you'd find 1 and 1/10. And this little portion right here, you'd find 1 and 1/10, and you'd shade in 1 and 1/10. When you're all done, if it should be shaded into, say, a leg. Now, if you just shade in a leg, and then I look on your work and I don't find the word for it, then boom, shakalaka, points gone. Because that's really the way I roll. So let's do next. Let's do 19. Brooks,
Yeah.
you had your hand up, so
All right.
I'm assuming you had a question.
Here. Stuck it on the paper, but it's not that exact thing.
Well, if you have your work shown, then you're good.
And
If you don't have your work shown, then you're not good. Then I take points off.
So, since like more than like half of my paper, like 8 questions, I'm gonna have points off because I don't have my work shown.
Yes. I'm glad you needed to clarify the fact that I said if you don't have your work shown, you will lose points. And then you asked, but if I don't show my work, do I lose points? I'm glad you clarified that. It's important for you to all understand. So let's do number 19. Number 19 is a little tricky here. They try and fool you on number 19. Brooks, put your hand down. I've answered your question. The king's ship sank with 8 gold bars aboard. The king paid Captain Nemo 4/5 of 1 bar. The 8, I'm not answering a question in the middle of me doing the problem. The 8 bars has nothing to do with this problem. Because he didn't pay him 8 bars. He paid him 4/5 of 1 bar. He paid him 4/5 of 1 bar for finding the gold. The captain then gave half of his gold to charity. What fraction of the bar went to charity? So let's ask Justin, how much gold did the captain give to the... Just let it go. How much gold did the captain give?
1/2.
No. The captain gave
Oh.
Nemo... The king gave Nemo how much? 4/5 of a bar. So he has 4/5 of 1 bar. And how much of that did he give to charity?
1/2.
1/2. So I want to find half of 4/5. Which really, I mean, if you think about it, where are my fifths? Do I have fifths? Oh, there we go. If I had 4/5 and I wanted to find half of 4/5, and I just had, I would hate that some people are going to have to leave, and I wanted to just find half of 4/5, it's really simply 2/5. But if we want to do the math, I have 4 over 10, so multiply straight across. 4 over 10 needs to be simplified. And it simplifies down to 2/5. So now you should have the answer to 9, 13, 15, 16, 17, 18, and 21. So for those of you who are like, I didn't finish it. Well, I've given you already more than half of the answers. Let's... Oh, number 20 is a good one. 20 is a good one. Because really your answer is not in fractions in 20. Because if we read problem number 20, it say there are 40 students at Valley High who play stringed instruments. So we have 40 students. 40 students. So if you answered number 20 and you got a fraction, you've got something wrong. Okay? We have 40 students. 1/4 play the viola. 1/5 play the cello. And we want to know how many students play violin. Now I know I've explained to you that sometimes I do chop students in parts. But you can't. The person who wrote this question doesn't chop students in parts. So you can't have a part of a student playing a violin, which should have given you the idea that your answer should be a whole number. Like I don't have 4 3/8 of a student plays violin. That doesn't make much sense. So what you have to do, I need to find, are you writing any of this down, Brooks? Because I would think you'd want to, because you haven't finished it yet and it's at home, so you want to be able to take it home. I'm really trying to help Brooks get this done. So when he says he didn't have time today, I mean, really, he did. Okay, so I need to find first, I need to find 1/4 of 40. 1/4 of 40. So looking at that, Rainey, can you tell me what 1/4 of 40 is? 10. 1/4 of 40 is 10. You writing this down, Brooks? So 10 students play the viola. I also need to find 1/5 of 40. 1/5 of 40. Courtney, what is 1/5 of 40? 8. So 10 students play the viola. 8 students play the cello. The rest of the students play the violin. So Kate, ignore Brooks as he chokes to death. We'll just keep working. Kate, how would I figure out how many students play the violin? Okay, there are 40 students. Okay, so there are 40 students in this room. We're pretending. Don't count because it's not true. It feels like there's about 40, but it's not true. So there are 40 students in the room. What I do is I say, hey, if you play the viola, leave my room. And 10 of them are going to get up and go. And so now how many do we have left?
30.
30. Good, 30. Now I have 30 students in my room. And I say, hey, if you play the cello, get out of my room. And those 8 people are going to be getting out of the room. So now, once those 30 have left, or those 30 and the 8 of them have left, and I say, the rest of you play the violin, you're awesome. How many does that leave? 22. So there are 22 students that play the violin, which answers the question, which if you put a fraction on there, you're insaner than I am. 1, 2, 3, 4, 5, 6, 7, 8, 9 of these 21 you should already have done. Well, I've done and recorded on the video. So, JJ, why don't you pick one and we'll work it. Pick one of the problems. Number 10. All right, so we have 12 35ths times 15/6. 12 35ths times 15/6. 16ths. That's what I have. Gosh, they're always criticizing me and I put it up there. Now we multiply numerator times numerator. Denominator times denominator. So let me ask, Maddie, do you know 12 times 15 in your head? Ooh, she's going to show me because she has it on her paper. 12 times 15. Say it real loud.
It's 180.
That's not very loud. Stand up and say it louder.
Can I do it? It's
No.
180?
Yes! That's what Miracle whispered. It is 180. And see, I know 10 times 12 is 120. And then 5 times 12 is 60. It's 120 plus 60 is 180. I'm just thinking, breaking it apart, doing a little stuff with it. Just a little stuff with it. Maddie, do you know 35 times 16? Or are you doing that right now? 560. Maddie, proper or improper fraction?
Proper.
Proper. Good. Because the numerator is less than the denominator. Which makes it a proper fraction. Maddie, when you look at the bottom at the top part, we have to shade it in. Do you see 180 over 560? No. So what does that mean we have to do, Maddie? We have to simplify it. Okay, can you two stop holding hands back there? So, Maddie, what do you think we can divide by to get us started here? I mean, they both end in a 0, so that means they're both divisible by... Divisibility rules, if they both end in 0, they're divisible by 10. Good. I mean, there are other numbers, but since they both end in 0, I'm going to divide them both by 10. And 180 divided by 10 is what, Maddie? 18 over... Oh, good. 18 over 56. Is that on there? No, it's not. It's not. I can do it by what?
20.
I can't do this by 20.
No, like the...
Yeah, but I know, but now we're here.
Oh.
So now what can I do by this by?
Simplify.
By?
During the GC.
Okay. Yeah, but what is the number I could divide that by? Oh, thank you for giving me permission to take my chair. What do you think, Justin? What could we divide by?
20.
Not here. We have 18 over 56. So I'm at this point. We could have divided by 20 here. That'd be fine. But now we're down to 18 over 56. So what can I divide by both 18 and 56 by, Blake? 2. They're both even numbers. Blake, what is 18 divided by 2?
It's 9.
9. And what is 56 divided by 2?
28.
9 over 28. Is that on there, Blake?
Nope.
Yes.
Nope.
Yes. Is 9 over 28 on there?
Yes.
Yes, 9 over 28 is on there. Why are you arguing? You don't even have the paper. You argue just to argue. Okay, so I've done those from the bottom at the top paper. Now in my first class of the orange cards, I did 1 and 5. My second class, I did 6 and 3. So this class, I'm going to do...
7 and 8 and 4.
No, 2 and 8.
Let's do...
No, 5 and 4.
Oh, no, I already did 5. I already did 1.
2 and 8.
2 and...
8, 6.
No, 7.
I'm going to do 2 and 7.
Oh, man,
I've already done in my first two classes 1, 3, 5, 6. So now I'm going to do 2 and 7, which leaves 4 and 8 to do after school.
Oh, so we're doing the orange cards?
Yes.
When was the 21 card?
All right, so let's look at, I said number 2. Number 2 is 4/10 plus 1/5.
Oh, we're actually doing this.
4/10 plus 1/5. So if you haven't done the orange cards, or even if you have, it might be a good idea to write down these, because by the time we walk out the door, everybody who follows along and pays attention will have 2 of the 8 done.
And you know they're going to be correct because you are...
Only if you follow along and pay attention. So let me ask you something, Lawrence. Lawrence. This problem is written this direction. You know what it's called? Horizontally. Good. I always tell you to write it this direction. You know what it's called? Vertically. Good. So it... Number 2 is an addition problem. Number 2 is an addition problem.
But it says a multiplying.
No, we're doing the orange cards now.
Oh.
These are the orange cards. I've gone over 3 or 4 of the bottom at the top papers. I'm not doing that anymore. So we're doing number 2. Lawrence. Lawrence. Can I add these 2 fractions the way that they're written? Say no.
No.
No. Why not, Lawrence?
Because 4/10 is bigger than 1/5.
No. Which 2 parts have to be the same?
The bottom.
The denominators have to be the same. Lawrence, is 10 the same as 5?
No.
No. So I need to find the least common denominator for 10 and 5. Luckily, you all, if you have your journals, have a multiplication chart. So Lawrence, if I was looking in my row that started with 10 and my row that started with 5, what would be the first number that showed up in both rows? 10. And so I need to change. You're not just going to put an answer down, Brooks, because if I don't see the work. Nothing but floor. So now, Lawrence, this is already 4/10, so I don't need to change that. But Lawrence, 1/5 does not have a denominator of 10. So what would I multiply by here to give me a 10? So 5 times what gives me 10?
2.
If I multiply my denominator by 2, I must also multiply my numerator by 2. So 1 times 2 is what, Lawrence?
2.
So, and this is an addition problem. I always go back and look because some of you have missed problems on this the first time you did it because you subtracted when you're supposed to add or you added when you're supposed to subtract. So Lawrence, now I have 4/10 plus 2/10, which gives me... Good, so 6/10. Now, if you put that answer on your paper, I will mark it wrong. Lawrence, you know why I would mark it wrong?
No.
Right, because it needs to be simplified. It needs to be simplified. So, I could find the greatest common factor of 6 and 10. Or I could use my brain a little bit. Since they're both even numbers, Lawrence, every even number is divisible by what? 2. Good. Every even number is divisible by 2. And if I find my common factors are 1 and 2. Therefore, my greatest common factor equals 2. If I divide both of these by 2, 6 divided by 2 is what, Lawrence?
divided by 2 is 3.
And 10 divided by 2 is what, Lawrence?
5.
So 3/5 would be your correct answer for whatever number problem that is. I'm just saying.
I'm just saying you're not
Circle.
6.
I know, but you weren't writing as I went over things. You were like...
110, 2, 0.
Then I said I would do number 7.
I was.
And just a hint, when you turn this in, even though I'm doing them in different order, when you turn it in, I want the answers in the correct order. Because I'm not doing a scavenger hunt. Defined, where did he do number 1? What's that say? 4/5. Kate, what does that say for number 7? 4/5, subtract 3/10.
So the answer was just 2.
I don't remember.
Go back and watch the video.
Yeah, you have to go back and watch the video. All right. Cadence. Can I subtract these fractions the way they're written? Which of those two fractions is greater, 4/5 or 3/10? 4/5. Because if I'm taking away something, I have to take it away from the larger of the two numbers, or I'm going to get a smaller value. I'm going to get a negative number. So 4/5 is the greater of these two fractions. 4/5 is almost a whole, because 5/5 would equal 1. And 3/10 is less than a half, because 5/10 would be less than a half. So cadence. My least common denominator for 5 and 10 would be what? 10. So my least common denominator is 10. So I need to change these cadence so they both have a denominator of 10 without changing the value. It's like saying, hey, I want you to be home in 30 minutes. Your dad yells at you, says that. Your mom says, oh yeah? He wants you to be home in 30 minutes. I want you home in half an hour. We're not changing the value. We're just changing how it's written. Krista, for your birthday, I'm giving you 10 dimes. Oh yeah? For her birthday, I'm giving her $1. Well, 10 dimes is more than $1. No, it's not. They're the same. So we're just changing the way it's written. Would you rather have, let's say, 20 quarters all wrapped in a roll, or 20 quarters is $5, right? Or $5 thrown at you? Would you rather have 20 quarters or 5 $1 bills thrown at you?
5 $1 bills.
Okay, good. But they're the same thing, right? We're just simplifying the way it is. Because I don't want to walk around ching, 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 ching with the money in my pocket. Because that'd be annoying. All right, so this one, cadence, is already over 10. What do I have to multiply by here to get 10? 2 over 2. Because 5 times 2 is 10. Whatever I do to the bottom, I have to do the top, bottom. And cadence, 4 times 2 is 8. I check, and I see this is a subtraction problem, unless it has to do with this problem. I'm not answering questions right now. And I have cadence 8/10, subtract 3/10 is going to give me 5/10. Yay! Oh, that's the wrong answer.
What? Have to simplify.
I have to simplify. And 5 out of 10 equals 1/2. You should know your halves. Are you guys passing notes? Okay. So by the end of tutorials, you should have access to 8 of the orange cards. And there are only 8 of them. So you should get 100 on it. Which means if you've already turned them in and don't have 100, you probably want to watch the videos and get 100. I'm just saying. Boom! Shakalaka. Peace out. God bless. Love ya. Do something kind.